As a TradBiz executive or investor, what are the basics you need to know about crypto and Web3? My name is Randall Hancock. I'm the CEO of Accelerating Biz. In this video, part of the Web3 for TradBiz Executives and Investors series, we're going to cover the foundations you need to start addressing Web3 opportunities. Specifically, we're going to provide you with a crash course in how crypto and Web3 works, including blockchains and distributed ledgers, Crypto Trilemma trade-offs in blockchain design, different consensus mechanisms used in blockchains, what are smart contracts and how do they lead to different types of tokens, the emerging Web3 technology stack, crypto regulation considerations, including the U.S. Securities and Exchange Commission's Howie Test, and the difference between utility and security tokens. If you're new to Web3, this may seem a bit overwhelming, but don't worry. We've got you covered and it is not as complex as it initially seems. If you're already familiar with these topics, feel free to skip to the next video, Advanced Web3 Topics. Let's start with the blockchains and other distributed ledgers that provide the foundation for crypto assets in Web3. Think of a blockchain as a ledger containing transaction data and account balances, much like any other spreadsheet or database, but that are replicated, shared, updated, and synchronized across a distributed network of computers or nodes. The key breakthrough here is that blockchains provide mechanisms for ensuring that everyone using them agrees on the value of all the transactions, without any one entity owning or controlling the network. Blockchains solve the so-called double spending problem, preventing any specific crypto asset from being spent or owned more than once. A blockchain like Bitcoin works when a transaction is initiated by a user holding some of the blockchain's assets, or tokens. The requested transaction is broadcasted to a distributed peer-to-peer network of nodes, which run an algorithm to authenticate the transaction. These validated transactions are then combined with others to form a new block, which is added to the end of the blockchain. Each block records the permanent, time-stamped transaction transparently in an immutable or non-changeable manner. In this way, the requested transaction is completed with any changed balances recorded in the appropriate user's addresses. Many blockchains also provide additional functionality, enabling smart contracts, other kinds of digital assets, and the wide variety of use cases that we will explore later. Blockchains can be public, private, or a hybrid blend of both. Public blockchains like Ethereum and Bitcoin are permissionless, meaning that anyone with the appropriate technology and resources can participate. Blockchains can also operate privately, such as when organizations adopt technologies like Hyperledger to enable industry-specific supply chains and other processes. Still others, like Ripple, operate as hybrids, with transactions processed privately, but relying on a public blockchain for finality. Users interact with blockchains using wallets, crypto keys, and backup seed phrases. Private and public cryptographic keys determine the digital identity of users in crypto ecosystems, enabling them to complete transactions which are then recorded on the blockchain. These keys are stored in software or hardware-based crypto wallets. For a basic value transfer transaction, a sender signs a transaction using their public key, which is then validated by the network, transferring the value to the receiver's public address. Wallets increasingly allow users to recover their private crypto keys using a series of 12 to 24 simple words generated by the crypto wallet, which provides users with backup access to underlying private keys, even if the wallet is destroyed or lost. Every blockchain makes trade-offs between scalability, security, and decentralization. The Crypto Trilemma refers to how blockchains can only maximize two of three dimensions: scalability, decentralization, and security, which forces trade-offs in network design. Scalability is determined by network throughput, typically measured in the number of transactions per second. Security is the ability to ensure immutability of the data that has been recorded on the blockchain, as well as resistance to attacks from malicious actors. Decentralization is the degree of diversification in ownership, influence, and value in the blockchain. Every blockchain's design has made trade-offs that provide different profiles of scalability, decentralization, and security. For example, Bitcoin is arguably the most decentralized and secure blockchain, but is limited to an average of about 5 transactions per second and a 10-minute transaction confirmation time. Ethereum, an open-source blockchain with smart contract functionality launched in 2015, is the second largest crypto asset in market capitalization and provides the foundation for many Web3 use cases. Ethereum performs a bit better than Bitcoin, at 12 to 25 transactions per second with a 6-minute confirmation time, while still providing good decentralization and security. On the other hand, Solana, a competitive chain to Ethereum, processes about 2,800 transactions per second with an average processing time of less than 1 second. However, the Solana network is far more centralized than either Bitcoin or Ethereum, with just 1,800 validators compared to Bitcoin's 15,000 plus nodes and Ethereum's 400,000 plus beacon network validators. Blockchain teams continue to evolve solutions to address these Crypto Trilemma trade-offs. These solutions include developing more recent consensus mechanisms like proof of stake, enhancing layer 1 protocol performance with sharding to split blockchains into smaller partitions, and increasing block sizes to store more transactions. Newer innovations include creating layer 2 solutions like state channels, off-chain computing, and side channels that increase transaction volumes while leveraging the underlying security of an existing layer 1 chain. Blockchains also use different types of mechanisms to validate transactions and maintain consensus across their networks. Proof of work, or POW, was the first consensus mechanism implemented for a blockchain, commonly associated with Bitcoin. With proof of work, network nodes compete by solving mathematical puzzles in a process called mining to earn the right to create the next block in the chain. POW chains are often both decentralized and secure, but operate at low transaction speeds and high energy intensity, as miners need significant capacity of advanced servers to solve puzzles quickly. Proof of stake, or POS, was conceived to address some of the limitations of proof of work. In proof of stake, validators are selected from a node pool based upon the amount of crypto assets each has staked in the network. Transaction fees charged by the network are used to incentivize validators, with some platforms also offering block rewards. POS networks have the advantages of being energy efficient, performing at higher throughput, and maintaining higher security. However, they also risk higher centralization as the validators with the largest holdings have increased influence. Many newer blockchains use some form of POS as their consensus mechanism. Importantly, Ethereum recently transitioned from its original POW mechanism to a new proof of stake model, which makes Ethereum far more energy efficient and paves the way for planned scalability enhancements. Smart contracts are programs stored on blockchains that run when certain conditions are met. These programs consist of code, called functions, and data, referred to as state, that run when conditions are met and verified by the nodes. Smart contracts provide the building blocks for automating transactions and decentralized applications, such as transferring crypto assets, rewarding users, and sending messages or notifications. Smart contracts are often coded in a dedicated programming language like Solidity, Ethereum's JavaScript-like native language. Virtual machines are required to interact with and deploy smart contracts on a network. These are sandbox programs that emulate an entire computer system, including CPU, memory, and storage. The Ethereum virtual machine, or EVM, is the most widely used virtual machine. While native to the Ethereum network, the EVM has also been adapted to work on many competitive blockchains. Smart contracts enable blockchains to do much more than simply send and store units of value like Bitcoin does. In fact, the bulk of Web3 use cases discussed in this series are built on blockchains that make extensive use of smart contracts. Many different types of crypto tokens have emerged, with associated token standards to ensure that smart contracts and applications are consistent and composable. For example, Ethereum tokens are referred to by their Ethereum Request for Comment ERC number. ERC20 is the standard for fungible tokens, widely used in Ethereum-based projects in value, staking, governance, and other use cases. Non-fungible tokens, referred to as NFTs, often utilize the ERC 721 standard to develop and trade collectibles, profile pictures, art, access keys, and other virtual assets. A growing number of other ERC standards exist to meet a wide variety of use cases, such as preventing accidental burning of tokens, ERC 223, building more functionalities on top of tokens, ERC 777, bundling transactions, ERC 1155, and accommodating subscription models, ERC 1337. Web3 ecosystems are categorized into 4 layers that we refer to as the Web3 technology stack. Let's use what we've learned so far to see how this all comes together in this Web3 tech stack. It's useful to think about Web3 ecosystems categorized into one or more of 4 layers: protocols, enablers, applications, and wallets and custody. Protocols, such as Bitcoin and Ethereum, are the underlying layer 1 blockchains and other digital ledger technologies that process and store transactions. Enablers are layer 2 solutions that improve protocol extensibility and scalability, including helping to address the Crypto Trilemma challenge discussed earlier. These include Ethereum rollups, state channels, sidechains, oracles, and bridges. Distributed applications, or dApps, are layer 3 solutions built on top of blockchains that cater to specific use cases and value propositions. As we discuss later, there are already thousands of dApps operating across nearly 100 use cases at various stages of development and user adoption. Finally, layer 4 is composed of the mechanisms for using and protecting crypto asset keys and related data, including crypto wallets as well as institutional custody solutions. Crypto regulations are lagging, but they are catching up. This is a complex topic, as regulations are in flux and different across jurisdictions around the world. However, we believe it's safe to assume that regulators will increasingly address crypto and that a balance will emerge between enabling innovation while putting in place frameworks for taxation, fraud, securities, and consumer protection. The US currently treats crypto assets as property, which means that the gains or losses from trades are subject to capital gains taxes. The US Securities and Exchange Commission, the SEC, has also issued guidance that the sales of tokens classified as securities must be registered, expanding the use of the Howie Test to determine when crypto assets are securities. Exchanges offering security tokens trading must also be registered with the SEC. On the other hand, the US Commodity Futures Trading Commission, CFTC, classifies crypto assets as commodities under the Commodity Exchange Act, making them subject to the agency's compliance oversight. Crypto assets are also subject to anti-money laundering and know your customer requirements. For example, the Financial Crimes Enforcement Network, also known as FinCEN, published in 2013 that crypto service providers fall under money services, making them subject to AML KYC measures. Exchange users are therefore required to submit identity documents, addresses, credit cards, and bank account information as part of the registration or onboarding process. With both the SEC and the CFTC vying for control over crypto asset regulation, the market is waiting for more explicit guidance from the US executive and legislative branches that has yet to arrive. In March of 2022, US President Biden issued the executive order on ensuring responsible development of digital assets, calling for an interagency exploration of crypto regulation, including user protection, financial stability, national security, innovation, financial inclusion, and technological support. As a result, the US Treasury and Justice Departments released separate statements that they will be working closely with international partners to monitor and prevent illicit crypto asset-related activity, bridge regulatory gaps across countries, promote inclusive access to financial services, and develop standards for digital payment architectures. From the legislative branch, the U.S. House of Representatives introduced the U.S. Virtual Currency Market and Regulatory Act in 2021, which would have required the CFTC to recommend enhancements to existing U.S. crypto regulations, but failed to pass in the Senate. In June 2022, the Senate began reviewing a bipartisan proposal, the Loomis-Gillibrand Financial Innovation Act, which aims to guide the digital asset space, including making crypto asset transactions under $200 tax-free, defining most crypto assets as commodities rather than securities, backing stablecoins with fiat reserves, granting the CFTC with exclusive spot market jurisdiction over cryptocurrencies that are defined as commodities, and confirming the SEC and CFTC as the main regulators of digital assets. You should probably know a bit more about the Howie Test, which the US SEC uses to determine whether a contract, a scheme, or transaction qualifies as an investment contract, and is thus considered a security subject to disclosure and registration under U.S. Securities Acts. Based upon a 1946 Supreme Court case involving the Howie Company selling citrus groves to buyers in Florida, this 76-year-old test remains the centerpiece of the SEC's guidance for crypto projects. From the SEC's perspective, crypto assets are considered to be securities when they meet the following considerations. 1. There is investment of money. 2. There's an expectation from the investor to profit from their investment. 3. The investment of money is in a common enterprise. And 4. Any profit generated comes from the efforts of a third-party promoter or an active participant in the ecosystem. Even if you're not a lawyer, it's clear that the Howie Test definition is both broad and somewhat ambiguous, which not surprisingly continues to create challenges in the Web3 space. Given regulatory treatment, there are significant differences between utility and security tokens. While these differences are subject to change based upon proposed regulations, they do provide useful guidance when evaluating the regulatory implications of different Web3 ecosystems. Utility tokens are a unit of account that provide access to the functionalities provided by a network. In many jurisdictions, utility tokens are exempted from laws and regulations governing securities, and therefore are accessible to everyone. Bitcoin has been classified by the US SEC as a utility token, given its fully decentralized nature and history. Ether is also considered a utility token by many, including the US CFTC. However, some believe there is a risk of security classification due to the initial coin offering, or ICO, Ethereum's founders used to launch the network. Security tokens, on the other hand, are considered to represent a stake in an investment contract, such as the criteria outlined in the SEC's Howie Test. These tokens may act like or represent other tradable securities, such as stocks, bonds, and derivatives. As such, security tokens may provide financial rights, such as voting, profit sharing, dividends. Depending upon proposed legislation, they may also be subject to securities laws, such as the US SEC regulations and AML KYC. Tokens classified as securities by the SEC may limit ownership to institutional and accredited individual investors. Some Web3 projects have even excluded investors in certain jurisdictions, such as the United States, from investing in their tokens due to potential regulatory risk. This distinction between utility and security tokens may be transitory, as innovation is leading to a wide variety of additional token types, including stablecoins, central bank digital currencies, governance tokens, non-fungible tokens, that's NFTs, and more. The hope is that a consistent set of frameworks will emerge from the changing regulatory environment, providing better guidance on how to classify and manage tokens across a wide variety of use cases going forward. The crypto and Web3 basics we've covered in this section provide the basis for understanding more advanced Web3 topics. As a review, we started by defining blockchains and distributed ledger technologies, explaining how users interact with blockchains, use wallets, crypto keys, and backup seed phrases. You now know that the Crypto Trilemma causes every blockchain to make trade-offs between scalability, security, and decentralization. You also know that there are significant differences between energy-intensive proof-of-work POW chains like Bitcoin and proof-of-stake POS chains like Ethereum. We explained how smart contract programs are stored and run on blockchains, enabling a wide variety of functionality, token types, and distributed applications, or dApps. We've seen how Web3 ecosystems can be categorized into a Web3 technology stack that includes Layer 1 protocols, Layer 2 enablers, Layer 3 applications, and Layer 4 wallets and custody. Finally, we reviewed how crypto regulations are lagging but beginning to catch up, including a debate about which tokens are classified as securities versus commodities. Equipped with this new knowledge, you're now ready to tackle a few more advanced Web3 topics in the next video. If you found this video useful, please like it, subscribe to the Accelerating Biz channel on YouTube, follow us on LinkedIn, Twitter, or Medium, and visit acceleratingbiz.com for additional Web3 insights and resources. If you have feedback or questions, contact us on any one of these channels. Thank you, and see you soon.